Hello, in this video I will be talking about an experiment we did in a previous lab called the ideal gas law equation. So we will be using that equation to find the moles of the unknown substance or salt we used to mix carbonic acid, and we will be using volume, moles, the constant R, and T. So the equation we will be using is the ideal gas equation, PV equals nRT. So in my video I will go through the equation, I will go through a problem used to find the amount of moles of gas in the balloon, and then I will show you the result. Thank you. Go. Alrighty guys, so the ideal gas law is PV equals nRT. We are solving for N, which is the mole of unknown salt. So in the flask, in the next video you'll see there is a carbonic acid. We will start by pouring the unknown salt into the balloon and put the balloon over the flask. From there will be a reaction and the balloon will fill up with gas. We know the pressure of the balloon should be 1 atmospheric pressure, and we will use the variables to solve for the moles of the unknown salt. So first, let's start by figuring out what each of these variables mean. P is pressure. Our pressure in our experiment will be 760 mercury, which is 1 atm. So then the next variable is volume, which is V. We found volume by finding the circumference. In order to find the circumference, we took a string, which you will see in the next video, and we wrapped it around the balloon to find the circumference, and we measured that in centimeters. The circumference we found of the string was 38.5 cm. So the formula for circumference was 2 pi r. To find the radius, since we already know the circumference, we did r c2 pi. So the circumference was 38.5 c2 pi. That equals 38.5, 6.28. Our radius then became 6.13. Now to find the volume of the balloon, the equation we used for volume was 4/3 pi r3. We know pi, so we need to just plug in r, which was 6.13 to the third. We then got a calculation of 0.0018. Alrighty. Now our r, which is a constant, is 0.0821. Our temperature was 22 degrees Celsius. When we are doing the ideal gas law equation, we have to convert this temperature in Celsius to Kelvin. In order to convert it to Kelvin, we need to add 273 Kelvin. It was 22 degrees and the calculation was plus 273 Kelvin, and it should have actually been 295, not 294. So that was a miscalculation. So this is how we found the answers to the variables in the previous problem. So now I'm just going to throw out some numbers of some different variables, some different answers that we'll use, and then I'll use these numbers and try to find the moles of our gas. So let's say that our volume of the salt or of the carbonic acid was 275 milliliters. We'll convert that to liters, and that'll be 0.275 liters. The temperature, let's say the temperature of our gas was 100 degrees Celsius. We'll convert that to Kelvin. That would be 373 Kelvin. Our pressure of the gas, we said we'll say is 766, which is 1 atm. This is alrighty. So now we'll say our mass in grams is, by the way, our R, remember, is 0.0821. This is a constant. Alrighty guys, so now let's plug in the numbers. So pressure is 1. Volume, we would say, is 0.275. Liters. This is ATM. And R, 0.821, 0.0821. And the units for this is times our temperature, which we calculated as 373 Kelvin. Now when we calculate this onto the calculator, alrighty guys, so now we'll start by calculating what we just wrote down on our white board. 1 times 0.275 liters divided by 0.0821, our gas constant, times 373 Kelvin. Alrighty, so 1
times 0.275 liters, which is 0.275, and then we'll do 0.0821 times 373 Kelvin. Now we'll do the top number divided by the bottom number to find our moles. Our number in our moles
for N is now 0.00898. We need to keep in mind our significant figures. Since our significant figures are 3, we need to realize that the zeros preceding the 8 does not count. So it's just 898. So that would be 3 significant figures. Stop. So now that we know the moles of our salt, now we need to figure out the molar mass of the unknown salt, our molar mass. So now that we know our moles, we need to use the equation to find molar mass to figure out what the unknown salt was. So our equation for molar mass is molar mass equals mass divided by moles. We know our moles. So now we need to know the mass. In the experiment, we measured out 1.56 grams of the unknown salt in a weigh boat. We then took the weigh boat and measured out 1.56 grams of our unknown salt. So that is our mass. Our moles is 0.00898. Again, guys, excuse the bad handwriting. So now that we know that, we're going to go to our calculator and we're going to calculate the molar mass. Once we find the molar mass, we're going to look on our periodic table and we are going to try and come as close to the molar mass and find that molar mass and match it up to what we have on our periodic table. Alrighty. So now we took 1.56
grams of salt, and we'll divide it by our moles, which we found on our whiteboard, 0.00898. So now type that in, divided by 0.00898. This is how we find molar mass divided by moles. Our answer came out to be 173.71. So we'll round up, we'll do 174.
So now let's look on our periodic table and look for the molar mass. And it looks like the element would be deuterium. So hopefully we got as close to the answer as we could, but this is how we would find the mass or our moles of the unknown substance and come to this solution. Alrighty, so I hope that this would help you calculating the ideal gas law equation. I hope this video helps. If you have any questions, then read your chemistry book. Alrighty, thanks for joining me. Bye.